want to look at today is we just want to do a little bit of a review over solving equations. Now, let's just look at the most basic equation. Might be something like this. Okay, and this is just a one-step equation where all we have to do is just get rid of the 3 over here. And I do that by subtracting it from both sides, because one of the ideas that we use in solving equations is that anything we do to one side, adding or subtracting, we can do to the other, and the equation stays balanced. Now, we could have another one-step equation might look like this, okay, where all we have to do is divide by the 2. And we get x equals 5/2. So that's another type of equation. And then we can put the 2 together. So the next step is we might put, have 2x plus 3 equals 5. And now remember what you do, you're going to isolate the x term by getting rid of this 3, subtracting it from both sides. Now some people, you don't think about subtracting, you just think, well, I'm going to move it to the other side, and when it crosses the equal sign, you can think of it as changing signs. That's the way some people think of it. And when I took Algebra 1, that's the way I thought of it. It just seemed quicker to me. Now the last thing, I divide by 2, and I get x equals 1. Okay. So those are, that's a basic 2-step equation. Are there any questions? Everybody remember that pretty good? Now, we can add a step to it. For example, let's suppose we have 2x plus 3x plus 5 equals 4. Now we have a preliminary step where I need to add like terms. So here's what you do. First of all, you take both sides and add any like terms, which in this case I've got 5x plus 5 equals 4. Now after you do that, now you're back to a 2-step equation. You need to subtract the 5. That. And then divide by 5. Okay. So we can keep bumping up the level of complexity here by adding a parentheses. Maybe we have something like this. Let's suppose we have 2x plus 1 plus 5 equals 4. Okay. Now we just need to clear the parentheses. Now, we have this thing we call the law of distributivity that we say, well, we can just multiply through here like this. So we get 2x plus 2 plus 5 equals 4. Now, the reason this law of distributivity works, remember, is because, after all, what does 2 times x plus 1 mean? Well, it means 2 of these x plus 1s. X plus 1, there's 1 plus another one. That makes 2 of them. And you can see, adding like terms, we get 2x plus 2. So we just say, rather than work it out this way, we just say, use the law of distributivity. So that's what we've got here. Now, notice I've used the law of distributivity. Now I add like terms. Okay. Subtract. And then divide. And you get that, negative 3/2, which you can leave it in that form. It's an improper fraction, but that's fine. Okay. Top number can be bigger, it's okay. Any questions about any of that? Now, what usually will give us problems when we're dealing with equations is, well, probably one of 3 things: where you have a lot of negatives involved, or where you have fractions or decimals. So that's where you have to be careful. So, for example, let's put a negative in. Let's suppose you've got 2 minus 4x plus 5 equals negative 7. Now, you realize we're not distributing this 2 through. This is 2 minus this. Now, does anybody remember how you drop a parentheses with a minus in front? Yeah, yeah, just distribute -1, or you can think of it as just change all the signs. And remember, be watching for me to make mistakes. I'm not going to make one intentionally, but you get a sticker. I'm sure to make a mistake, so be careful. Watch. So there's what we have. Now, no matter what level of math, you always need to, when you see a problem with a lot of negatives, it means proceed with caution. You really have to slow down because there's a potential for arithmetic errors. If it's all pluses, you know, you can relax a little bit. But now look here. You've got a +2 and a -5. So there you have a -3. Okay. There's what you have. Okay. Now, I need to get rid of this -3, so I'll just add it to both sides. Or you can think of it as moving it over and it becomes positive. Now, all I have is 4x equals -4. Divide by -4, and you get x equals a +1. And that's solved. Okay. Any questions about that? Okay, so you know, this is just review. So all of you have seen these types of problems before. We're going to practice them too, but any questions? And you can see if I plug this back in, if I plug the 1 back in here, I get 4 plus 5, that's 9. 2 minus 9, yeah, that is -7, so it works out. Now, let's suppose we have a problem like this. Let's suppose we have x over 4 equals 5. We want to solve this. Now, this has got a fraction. It's a simple one with a fraction. The way we can get rid of a fraction, and this is often the first, you know, early on and you're trying to solve an equation with fractions in it, you want to clear out the fractions. And we can clear out the fractions just by multiplying through by the least common denominator, which in this case is 4. Okay. So notice, the reason we do that is because this cancels, and we just get x equals 20. Okay. Everybody see that? Now, if we go back, we can make them a little more complicated. Let's suppose we've got 2/3 x minus 4/5 x plus 3 equals 7. Now that's a little more complicated. But what you don't want to do, what I'd recommend is don't even do any type of addition or subtraction with these fractions. Just clear them out. That's one of the good things about working with equations. You can clear them out. I can multiply through by the least common denominator. I don't want to just multiply through by 3 because I'd still have a fraction here. I don't want to just multiply by 5 because I'd still have a fraction here. So what I'm going to do is I'm going to multiply through by the least common denominator, 3 times 5. And you got to do it to each and every part of this. Okay? So I just do it to each and every part. Notice 3 times 5 by the first, second, third, fourth terms. Now, what happens is this cancels here, this cancels here, and then nothing else cancels. So let's see what we've got now. We've got 10x. It's right here, this first one. Minus, it's minus 12x. Plus, now be careful with this type of multiplication. Some students might say, well, this is 9 times 15. They would try to distribute that 3 through. But remember, you can't do that with multiplication. Because really, this is saying 3 times 15, right? It's not saying 9 times 15. It's 3 times 15. So this would be 45. Equals, okay, this one right here. What would this one be? 15 times 7, what would that be? You know, doing this type of thing in your head sometimes is difficult. I'll tell you the way I do it. I think of, okay, 15 times 7. I think of, well, 10 times 7 would be 70, right? And then 5 times 7 is 35, right? So 70 and 35, what would that be? 105. Is that what 7 times 15 is? What is it? What did I do wrong? Okay, so look, here's what I get. Let's do this. I've got 15 times 7. Okay. So then I've got, let's just go old school here. 7 times 5 is 35. 7, 8, 9, 10. Right? So 105. Is that right? Okay. There it goes. So, okay, so we have 105. Now, let's see what we've got here. We've got negative 2 plus 45 equals 105. Okay. Now, remember, this negative popped up here, so I had to be very careful here. You know, positive 10 and negative 12, negative 2. Then I'm going to subtract 45. So here I've got negative 2x equals, now now we've got this one again. What would be the answer here? 60? Okay. Positive 60, right? Okay. And then divide it by negative 2. And we're just going to have x equals negative 30. Okay. And there it is. That seemed like a lot of work. But remember, all we do is we clear the fraction, we multiply through by the least common denominator, and the fraction's clear. And then we can just go through and work. Now, something else that will give us problems is these decimal equations. Let's suppose we have something like, well, recall this. Think about this. Let's suppose that we have 0.5, and let's suppose I multiply 0.5 times 10. Well, we know that that's going to be 5, right? Because multiplying by powers of 10 moves decimals to the right. If I take 0.5 times 100, that moves it 2 places, and so forth. In other words, I can use this idea to do what's called clearing decimals, realizing that I can multiply both sides of an equation by 10 to some power. So let's suppose I have 2.3x plus 4 equals 5, something like that. And I want to clear this decimal because I don't want to work with it. I know I'm likely to make a mistake. So I'll just move all the decimals one place to the right, just enough to clear this one. So if I do that, I get 23x plus 40 equals 50. Now I'm free from the decimal. I don't have to worry about doing this decimal arithmetic. Subtract 40. And we get 23x equals a lovely 10. Divide by 23. Okay. There it goes. And, you know, depending on how they want the answer, they may want it back in decimal form. In that case, you would go ahead and divide it out. Otherwise, you could just leave it like that. Any questions about that? Now, notice here we had just, all we had to do was move the decimal one place to the right. Sometimes our problem is going to be a little bit more challenging. Let's suppose we have 2.3x plus 2.75 equals 4, something like that. Now notice, if I move all the decimals one place to the right, I still have a 27.5 here. So what I have to do is ask, well, how many decimal places do I need to move everything so that all the decimals are clear? Well, 2, right? So this would be 230x plus 275 equals 400, right? Yeah. Okay. Now, subtract the 275. And you get 230x equals, what's that going to be? 125. Well, yeah, 125. And then divide. What, 230? Okay. Now, I wonder, can we reduce that? I think we probably can, can't we? 125, let's see here. I know 5 will go into both of those. In fact, 5 will go into 100 20 times, right? So, and it'll go into, and then we got 25 more. So, what's that going to be? Is that going to be 25 over 46? Is that okay? Does everybody agree with that? Okay. Okay, so there's your answer. And you can just leave it in that form. Okay, any questions? Now, of course, what we had here, we had all numbers. You know, sometimes we don't necessarily have to just have all numbers in one variable. For example, let's look at this. Let's look at this famous equation, equals MC squared. And let's suppose we want to solve that for m. Well, all I need to do is just divide by c squared. And there we have m is equal to e over c squared. So a lot of the equations that we're going to encounter are going to be formulas like this. So for example, let's suppose we have, let's say we have k equals 4/9 q h. And let's suppose we want to solve for, let's say q. We want to solve for q. Well, probably, how would you start? How would you start this? Yeah, now distributing that fraction will work just fine. That's a good answer. But I prefer to clear the fraction so I don't have to do any arithmetic with it. And there's not a lot of arithmetic I'd have to do here, but I'm going to multiply both sides by 9. And that way I get 9k equals 4 times q plus h. Now I've got the fraction gone, and I'll just distribute this 4 through. But what you said about distributing, that was absolutely correct. That's perfect. So here we have 4q plus 4h. Now what would you do? Remember, we're solving for q. Yeah, that's right. Minus the 4h. So we have 4q equals 9k minus 4h. Yeah, divide by 4. Okay. Now, there's the answer right there, 9k minus 4h over 4. Another way you could write this answer, you could write it this way, 9 over 4k minus h equals q. Because look, I can divide the 4 into the 9, give this its own term, and then give this its own term. See, so you could have 9/4 k minus h. And I think Math Excel is going to have you put it in this form, I believe. Okay. Any questions about that? Well, of course, so this is the basics of how you solve equations, just a little review. But of course, really, you get the hang of it just